Good morning and welcome back again. Today we have 11.5, 4. It's going to talk about graphene polar. So as you know, we have polar coordinates and in the polar coordinate we have a graph. So we see that before, if you want to sketch a graph, you should start with a point. If you want to start with a point, you should start with the angle. And after that one, you will get the point that we want. And before that one, I remember that I was about to give you some clue about the angles. So the angle is very important, especially when you are going to deal with the quadrants. For example, if you want to find sine or cosine without using calculator. So I think we took in the cal one, but I'm going to repeat it here. The first things, we have an angle. We know that point is like a circle. If you have a circle, this point, if the radius is 1, that point will be 1 and 0. Am I right? And that point will be what? 0 and 1. And that point will be, yes, and that one will be 0 and negative 1. Okay. And as well, you know about that one is the x and y axis. So we have x and y location. That one will be for x, that one will be for y. And as angle, you know also about that this angle, if I count that angle, it will be what? The theta will be 0 here. When you are going to there, the theta will be 90, it's called pi over 2. Then you are coming to here, your angle will be 180, we call it as a pi. Then here angle will be what? 3 pi over 2, 270. Then later you will get 2 pi is equal to 360, right? And do not forget about that when we say x and y, and we have a transformation between x and y. We say that the x location will be cosine of theta, and y location will be sine of theta. Do not forget about that. So we have a cosine and sine, x and y. So we are going to use this chart, this circle, to evaluate the angle. What do you mean like that? For example, without memorizing, without using calculator, how do you know sine of pi equal to what, or cosine of pi is equal to what? So as usual, we are going to the angle here. I say here's pi, and here's negative and positive, or x and y. So I have that one as the cosine, and that one will be sine. Why? Because we say that if you have -1 and 0, means that cosine is -1 and sine is 0. So that's all about the angles. How about, for example, sine of 3 pi over 2? Can you tell me? Where's the angle? Here's the angle. So I'm talking about sine. So I have y location. So I'm going to write -1. Understood. How about if I say, tan of pi, I know is equal to sine over cosine, right? So it's equal to what? Was undefined. Am I right? Sine over cosine, so it's undefined. Is right? No. That one is 0. Look at here. So careful. That one is cosine and sine. So here's 0. Here is what? -1. So I will get what? 0/-1, then the result will be 0, is not undefined. So be careful when you are going to use the x and y axis. Do not mix between them. Shall I repeat that one? Huh? We have what? We say in the sine angle, here we are. We say in the pi, we have -1 and 0. So it means that cosine pi means that sine pi. Okay. So that's why here sine is equal to 0, cosine is equal to -1. When we say tan of pi, as you know, tan is equal to what? Sine over cosine. So I will get 0 is equal to 0. Also, you can find any angle that you want from here. So you get 0. Here's the cosine of 3 pi/2. For example, if I say find secant of 3 pi/2. So you know secant is equal to what? 1/cosine. So I'll get 1/0 and define. You got it. This circle is useful for the whole right angle, or let me say the origin, the basic angles, like what? 0, pi/2, pi, and 3 pi/2, then 2 pi. So how about if I have angle from here and there and there? Like what? Like what? Pi/6, pi/4, pi/3, and these two angle 0 and pi/2. So if I divide or I need a reference angles, this is called reference angles. These angles that we are going to use it more and more. So maybe angle number 1, 2, 3, we don't need more, right? But 3, 30, 45, 60 is more usual. Use it. Also 0, pi/2, and go on. So to find in the reference angles, I'm going to use the first quadrant, and we see we have sine and we have cosine of theta. Okay. Maybe the angle is equal to 0 in the first quadrant, right? Maybe pi/6, maybe pi/4, maybe pi/3, finally pi/2. طبعا you know about 0 and pi/2, right? From the circle. But I'm going to repeat it here to get more information. So this is for sine and cosine. Then this is for cosine, sine of theta. Yalla. So we are going to use fraction. We make this a quotient or fraction. Then we are going to put the denominator for all of them 2. Then you are going to use the square root. Easy, right? Then you are going to put the numbers from what? From 0, 1, 2, 3, 4. How about for cosine? 4, 3, yeah, descending. 4, 3, 2, 1, 0. Then you know 0, square root of 0, 0/2. So that one will be 1/2, and that one will be 1. Sorry? What's 1/square root of 2? Here, you mean here? Here? You mean here? Okay, we don't need to do it. So, okay, you can do it or you can leave it. Okay, yes, you are right. You can also try to simplify the denominator, or you can leave it like that. So, okay, the same. Good. How about here? 1. How about here? How about here? 0. Understood? Okay, now maybe you ask about cosine of pi over 6. So I say here's cos of pi over 6, and here's cosine. So I say is equal to square root of 3 over 2. You don't need to memorize it, just try to use that. Or maybe you ask about sine of pi over 4. So I go to the pi over 4. Here I am. And sine is the first cell or first column. So I'll get like 2. Or maybe in some book, like that. You can leave it or you can use that one. I prefer that one to not make confusing. To not be confused between them. So tell me about tan of pi over 3. Yalla. Yes. First, we have a sine over cosine. So, over, am I right? That's tan. So tell me about cosecant of pi over 6. So I say cosecant is equal to 1 over sine. So let me find pi over 6. 1 over 2, right? So it will be what? Easy. So tell me about cotan of pi over 2. You can use here or the previous one, the angle. So I say is equal to cosine over sine. Cosine over sine, right? So I'll get what? 0. Understood? Easy? Okay, so how about angle if you, and you know about the quadrants, for example. Here's sine and cosine, both are what? X and Y, both are positive, positive, am I right? So it means that cosine and sine positive, right? So how about here? X-axis is negative, so it means that cosine negative, sine positive. How about here in this quadrant? So of course, both are negative. How about here? Cosine is positive, sine is negative, is like that. And how about, for example, odd and even? Odd and even function. We have 6 functions, right? Sine of minus theta is equal to minus sine theta. So it means that's odd. And cosine of minus theta is equal to cosine theta. So it means that it's even. Means that if I give the negative, I'll get positive in cosine. So all functions depends on the sign, or the sign in it is the odd. So tan, what else? Cosecant, you are right. Cotan and cosecant, right? All these 4 are odd. It remains cosine and secant are what? These 2 are even. Good. You have these situations. This is the. So what's the benefit of odd and even function, right? What's the benefit? So for example, if I say find sine of minus 3 pi over 2, you can say I'm going to use 3 pi over 2. And you know sine of 3 pi over 2 is equal to minus 1. So minus 1, it will be 1. You got it? How about, for example, I say cosine of minus pi over 2. You say cosine is an even function. So it's better to think about what? Pi over 2. So I have what? Cosine of pi over 2 is equal to 0. You got it, Jamaat? Good. Now you have a homework. to find the angles here and here and there. You can say, I have 90, right? I have 90 here, pi over 2. And pi over 2 plus 30 is equal to what? 120. Why I say 30? Because I have a 30 angle here, that's why. How about pi over 2 plus 45? How about pi over 2 plus what? 16. Understood? So these three angles is homework for you. Of course, here homework. Of course, here homework. So use these three. Find these three quadrants, how to find the value of them. And how we use this table, the table of first quadrant, to find the value of the second quadrant. For example, if I say sine of pi over 2 plus, let me just write here, pi over 2 plus pi over 6, right? So is equal to what? 4 pi over 6 is equal to what? 2 pi over 3. Am I right? So I say find 2 pi over 3 is equal to what? So use this information, basic one, references, how to use it. Please check it in YouTube or in Google. Then use the reference angles, pi over 3, and you will see the result. Yes?
When you were trying to use it,
Mhm.
also the mention, like finding angles, so like 100,
No, it's not like that. No, like by 120 by. No. I see it's the reference angle. When you check it, you know what I mean. So use the reference angle, find it. That's a homework for you, actually. So your question is about homework. What?
When you have like, for example,
Silent, please. Silent, cannot understand.
and then you have a value that they pi, which is 180.
For example, you have 8 pi, you meant something like that? Okay. So how many, when you have 8 pi, it means that you have what? So in which section, in which quadrant? For example, we have a 2 pi, 4 pi, 6 pi, 8 pi. So you are going to think about like a 2 pi or 0, the same. Of course we need. No, it's not like that. Use the reference angle. So here's 2 pi is my reference angle, you know? So 2 pi is my reference. Why? Because I have a 2 pi, 4 pi, 6 pi, 8 pi. So it's the same location. We say that in the chapter 11.3, we say we have infinite point here. So think about it, that 8 pi is here or there. How about 9 pi? Look, everything changed. 1 pi, 2, right? 3, 4, like that, till 9. You got it? So you are here in the 9 pi. So it's not about to multiply by pi. No, find the location and reference angle. When I say reference angle, maybe you say just something. No. When you check it, you know what I mean by reference angle. So it's called reference angle. Reference angle means that these points and with the table's angle, the table's value. So kindly check it and you will see. Now you have at least 80% of the angles. So try to discover the 20% that remains as a homework. Understood? Good. So we are going to talk about something here. How to graph these things and how we find the value of them. Okay. First of all, we have what? We have symmetry. Symmetry means what? We have three things about symmetry of angles. or for the points. We have symmetry about x-axis, y-axis, and the origin, about the origin. So what do you mean by the symmetry? If I have a graph here, for example, I have a triangle here, when I say symmetry about x-axis, now if you look at the point, if you are concentrating on the graph, sometimes you are going to use polar and sometimes you mix it with the xy axis, because I told you this is for using or make it more easier for you. Otherwise, you cannot imagine all these points together in polar coordinates. So if you have a triangle and your mirror is x-axis, so you'll see, for example, the graph is like that. Understood? Like you are going to the swimming pool and you see your reflection or your image in your face in your picture. When we have about x, when we see about y-axis, means that if I have triangle like that, here will be like that. Okay? Here will be like that. So in that case, in the second case, y-axis is my what? Is my mirror, like a Holmes mirror. You are looking at in yourself and you are touching your right and your image is left side, right? So this is the mirror. And also, as well, we have what? We have a symmetry about origin. So origin will be the mirror. So you can see this part. In that case, you have the image like that. Can you imagine that? So if I have something here, instead of here or there, I have something there. So this means that the origin is the mirror, or is the symmetry about the origin. So in polar, how we deal with that situation, how we know about them. Actually, you should guess it. For example, if I have a point here with r and theta, I have a point P here, P1. So tell me about the x-axis. Tell me about the point here, P2. It should be what? How we bring this point to here? And you say reflected. By what? Exactly, negative theta, negative angle. For example, if this point is what? Is 2 and pi over 4. If I say it reflected about x-axis, so means that it remains here and what? And is what? As, yeah, 2 and negative pi over 4. This is one case, right? How about the second case? Give another case to be reflected here. Pi over? So pi over 4, negative 2 is coming to here. Am I right? Pi over 4 and negative 2 is coming to here. So no. But you are close. Well done. And you did. So you should go to the second quadrant, right? To come here. So this angle, if this angle is theta, so if I want to come to this angle to the same, I say what? Let me fix the angle first. I say pi minus theta, am I right? For example, if till here is pi over 4, if I wanted the same angle with the x-axis, I say what? I say pi minus pi over 4. Am I right? Here's pi over 4, and I want to find another one in the other side of my hand. So I say what? Pi, look, pi, just like that. I say pi minus pi over 4. Understood? You got the image? So I'm the origin. I'm in the origin. So this is pi, what? This is pi over 4. How about that one? No. Sorry, this is pi over 4, yes. And that one is pi minus over 4. I got the same. How about if I want to find something like that? This is minus pi. How about that one? Pi plus pi over 4. You got it? So I'm in the x-axis like that, my shoulder. Okay. So that's why we get what? Pi minus pi over 4. Then minus r, right? Minus 2. So I will get what? I can say P3, we do it by green, pi minus pi over 4, or theta as usual. And then here it will be what? P3 minus r back and pi minus theta. Am I right? You got it, Jamaat? Good. So think about it. I have pi minus pi over 4 and r minus 2. Then I'll get P3. Did you understand? Dears, do you have any question about the first point? Because later I'm going to the y-axis. So kindly ask me here. No question? Good. Now about y-axis. I want a symmetry. Okay, about y-axis. So it means that I have P1 here. And I want to find P2 here. Am I right? Because y-axis is what? Is the point. So tell me how we change that one, how I get P2. This is r and theta. Think about it when I say r and theta generally. Think about it, you have 2 and pi over 4. Yallah. How I get this reflection of that point, how I put this point to the other side. The point is here. I'm going to bring it to the other side. Okay? Minus 2 minus minus pi plus pi over 4. Minus is coming to here. That one is coming to here. Think it easy. We see that before. Pi minus pi over 4 and r. Right? Pi, listen, Jamaat. Okay, pi minus theta, pi minus theta, A, and already positive. That's it. For example, I say 2 and pi minus pi over 4. So here's pi, here's minus pi over 4, and here's 2. Yes, why not? Look, first, till here, I have pi over 4, right? We say pi minus pi over 4. You got that one? Good. So R2, I want to bring it to here. I want a P to be here. I don't want that point. I want to get the point here. Reflecting about y-axis. Y-axis. Okay, yeah. So in that case, you have that one. So give me P3 at the same location, yallah. Means that, like here, say this is my ear, and that one is my ear, and that one is also my ear, like that. So find the other way to get the P2, to go to the other side, to reflect with the y-axis, yallah. So one of them by angle. We change that one by angle. Think about the second by R. Minus, yeah. Look at here. This angle is minus theta, am I right? This angle is minus pi over 4. Let me say that. Am I right? Hello? Okay. Here is minus pi over 4. Okay. So minus r coming to there. So I say this point P3, you can find it by minus r minus theta. So minus theta come down. Minus r, go to here and you'll get the result again. Understood or not? Look at here. I have y-axis. I want to bring this point to here. I want to multiply, find angle, change anything that I want. So I see here, for example, is pi over 6, like that. Pi over 6 is 30, right? So that we here till this point. I see that one's pi over 6. So I'm going to down by pi over 6. Okay. Here I am, then minus r. So here I am positive 1, positive 2. So negative 1, negative 2. So that point will be negative 2 and negative pi over 6. Understood? Hello? I told you point is very important. You can see every time, every day we need to review the points. How to imagine point. So minus pi over 6, minus 1, minus 2. Yes, Kaka? What do you mean by positive? Why? No, forget about the symmetry, okay? Forget about it. Just sketch these 2 points for me. And P1, P2, yalla. Just these 2 points. So first point we say, be with me. Forget about it. Be with me. Look. The first angle we say what? Pi over 6, right? And 2 positive. So this is the point 1. Am I right? Do you have any problem? How many units? 1, 2. Question? No. How about that one? First, I'm going to think about angle. So angle is what? Minus pi over 6. So minus pi over 6. That one is pi over 6. That one is minus pi over 6. So minus 2, minus 1, minus 2. I'm here. Am I right? Or P2. If you put x, y axis, now you get the idea. Understood? I want to make a y as a reflection point, as a symmetry, as a mirror. So that's one. Now it's easy, right? So just sketch the point and you understand. So that's why generally we say maybe r theta, if I say is symmetry about y-axis, I say r theta change it to minus r minus theta. Now you know what I mean. Minus theta minus r to change to the second quadrant or to any points that I want. Or r theta is changed to what? Pi minus theta and r. So that one by changing r, that one by changing angle, theta. Understood? Good. The third symmetry is what? About origin. So think about that one. I have a point here, P1. The name is r theta. If you don't understand what's r theta, put it in 2 and pi over 4, as usual. So I want to bring this point to what? Third quadrant, to here. So how? Theta plus pi. R theta, yes, r theta plus pi. That's by angle. How about by r? Just minus r, right? Easy. So just put it as a P3, just minus r and theta. Why? Because if I have 2 and pi over 4 and minus 2 and pi over 4, the P1 and P2 will be like that. P1, 1, 2, pi over 4. How about P2? Pi over 4 minus 1 minus 2. So this one will be P2. So that one, if I sketch the axis, and I know I see this point and that point are reflecting about origin. Understood? Or pi plus theta, or just r. So you can see from here, these all mentioned the symmetry about x-axis by changing r theta to what? To r minus theta, and also symmetry about y-axis by changing to the r minus theta, and also r theta by getting minus r minus theta, and the other one. So one of them is applied, means that symmetry about x-axis or y-axis or origin. Do you have any question? Do you understand from these pictures, dears? Can you imagine that one and that one? And that one and that one? And that one and that one. Now you know what's the symmetry. Symmetry is very, very important, especially for the application of it. For example, we are symmetry. This point is the same. Here's the y-axis. This point is the same here. When you are going to the mosque or the temple or anywhere, you see the right side is the same as a left side. When you look at in the carpet, right, you can see the design of the right is equal to the left. If there is no error, طبعا. If there's an error, so something else. Understood? Good. So that's about symmetry. And later, we are going to use that one during the graph. It's very important. I'm not going to sketch whole the story. Half it is enough. From 0 to pi, if I know how to sketch and I prove that image, that function, that curve are equal to something, a symmetry about x-axis, so I say what? I say like an apple. Here's the other part. Understood? If I have that one and 100%, I'm sure about that. Sorry. 100%, I'm sure about it's this curve is symmetry about y-axis, so I say I have the same model to the left side because it's a symmetry. When I say find the area of this one, this curve, if you find the half area, you multiply it by 2, you'll get the area that I want. Maybe you have a leaves, rows. This is the symmetry about, look, x-axis. Understood? Symmetry about y-axis. Symmetry about origin as well. So if you know how to sketch one pedal, the other will be what? The other pedals will be the same. If you find the area of here, you can multiply by 4 and you get whole story. So careful, that one's details. So we are going to give you the detail, one of them, or one by one, but you should understand and get the idea. So, any question? Yes? Okay, now, we have a slope here. The slope, the slope depends on what? We mentioned that one in the 11.2. When you say calculus of the parametric, find the tangent line. Do you remember that? We say the slope is depending on what? Derivative. So the derivative of polar here, we have a rule. You know dy by dx, and y is the function of what? You can see y is the function of theta, and x also is a function of theta. There we had what? T and t. Now here we have r, theta, and theta. So you say dy by d theta is equal to dx over d theta. And we know the derivative of the function here is by what? Is by sine, because y is equal to sine, and then x is equal to cosine. And the final rule will be like that. This is the final rule. F prime sine theta plus f cosine over f prime cosine theta minus. So we have two different things. Let me highlight it for you to recognize what's the difference here. That positive and negative, and sine cosine, sorry, and sine cosine, change it. So f prime f, like that. So the whole story is what? Y prime, or slope, dy by dx is equal to f prime sine theta plus f cosine theta, and the reverse, use the reverse, cosine theta minus f sine theta, and maybe they give you the point r and theta is equal to something, and you'll find them. So what's the f prime? That's the question. What is the f prime, and how we find the graph of it, how we find the derivative? I don't think so is solved any example here. So maybe you'll face the example in your what? In your exercise. Let me just find them. So here's the slope, here's the r. This is the question. So you see r equal to minus 1 cosine theta. Look at here, the question. Find slope when r equal to 1 plus cosine theta. Okay. And theta is equal to what? Pi over 2. Let me see, just pi over 2. I'm going to take that one. So find the slope. So how we answer that question? By derivative, of course. So we say derivative is equal to what? We say r prime or dx or y prime is equal to derivative of here. So derivative of here is equal to what? Minus sine theta, and multiply by what? The rule sine. No, sine, careful. It's okay if you make a mistake today. It's okay because the first time. So you have sine, okay. That is the rule. Plus f itself multiply cosine theta. Again, it's the rule. Over r prime or f prime. F prime means that r prime or dr by d theta. So again, negative sine of theta multiply cosine of theta minus itself sine theta, and add pi over 2. Understood? So pi over 2, sine of pi over 2 is equal to what? 1, right? Yeah, so 1 by 1, I'll get negative 1 plus 1 plus 0 multiplied by 0, so I'll get 0. Am I right? That one 0, that one 0. Cosine of pi over 2 is 0, so you multiply by 0. Again, that one cosine is 0, so I'll get 0 plus, minus. That one 0, but that one 1. So 1 by 0, 0. 1 by 1, 1. Am I right? So I'll get what? Y prime is equal to 1. That one will be the slope at theta equal to pi over 2. You got it, Jamaat? The slope should be what? Number. Slope is like that, like that. So number is the number, the output. Do you have any question about the slope? It's easy. So when you see f prime, means that you have r or theta. Okay. Question? No question? So how we sketch that one? And after that, yes. How we sketch that? Later, I'm going to provide you many shapes. I'm going to give you the shapes with the example with the R. The important things to understand how to sketch that one is very, very important to how we start with it, how we show the steps to the teachers. That's very important. So R equal to 1 minus cosine theta is the simplest example that I'm going to start with it. So careful and try to understand. Is there any angle? No. Does he say anything? No. So the question is what? Just graph it. Okay. So how we graph it? First step, let me say A, symmetry about x-axis. We should test it. So test A is testing of symmetry. A symmetry test. Okay. How we test that one? How we test it? How do you know that one is symmetry about x or not? Just persiaraki. Nothing else. One line. Graph the following curve r equal to 1 minus cosine theta. So we need all information from 11.3 for all of them, then we can sketch. No, first step is symmetry. We should find the symmetry. Because time consuming, help you to do it correctly, nicely, and shortly. So listen to me. Listen, Kak. I'm going to test about x-axis. We say in the x-axis is we have what? R theta changed to what? Yellow x-axis. R and minus theta. Am I right? X-axis. R theta should be the R minus theta. Do you have any problem with that one? Or the second one? We see. Okay. So what do you mean by that? So it means that you have R equal to 1 minus cosine theta. This is the original one. Am I right? Oh. So I'm going to change each angle by here. Okay. The result of that one it will be what? Y. Cosine is what? Even function. We mentioned many things, but here we use all of them with a detail. So that one will be your new equation. So compare that one with that one. Is the same or not? Same. So origin is equal to that one. So it means that is symmetry about understood. So you don't need to sketch all the image from 0 to pi is enough for taking the angle. You got it? So now maybe it's a trick example. So find symmetry or test symmetry about y-axis. So I see what in the y-axis? R theta is equal to what? Minus R minus theta. Minus theta minus R. Am I right? R theta, here I am. I want to come to here. So I say minus theta minus R. Minus theta minus R. Understood? So I'm going to what? I'm going to change R equal to 1 minus cosine theta is equal to what? Origin equation. I'm going to check S. If I put minus R, minus theta, it's the same or not? So if I say minus R, 1 minus cosine theta, R will be minus 1 cosine theta. Am I right? That one will be my equation. Equation, origin equation is equal to star? No. So it's not symmetry about 1x. How about origin? About origin. So r theta is going to be what? Minus r theta. R theta, here I am. I'm going to go to there. So r theta is equal to the same minus r. So I'll get what? R equal to 1 minus cosine theta. My original example, it will change to, it's not equal, right? Am I right? So it's not symmetry about origin. You got it or not? So you should test them. But later I'll give you many or 3 point notes about the symmetry, how to find them quickly. Or if you test 2 of them, you don't need to test the 3rd one, but if you are sure about it. So now is points. Second step. First step, it was about symmetry. A, 1, 2, 3. So B, second step, is about what? Points. Or important points. IP. So what do you mean by important points? I know I have angle, I have R, and I have R and theta. Am I right? Let me make it nicely, that one. I know I have angle. I have R, which is equal to what? 1 minus cosine theta. As well, I need to find R theta because I need a point to sketch it, at least a little bit. So because symmetry about x-axis, I'm going to use 0 till pi. I'm not going to 2 pi. You know why? So 0, pi over 6, pi over 4, pi over 3, pi over 2, pi. So I get what, Jamaat? Yallah. If I put 0, I'll get 0. Right? If I put pi over 6, cosine of pi over 6 is equal to 1 minus pi over 6. I cannot remember actually. Let me see. Cosine, yes. So equal to what? 3 over 2, forget about it. Now pi over 6, and I don't know now, pi over 4, 1 minus square root of 2. Let's also forget about it, I don't know. Pi over 3, 1 over 2, so I'll get what? Am I right? That one is easy. What else? Pi over 2. How about pi 1 minus minus 1. Am I right? So I'm going to use these information to get what? To get the graph. So 0, 0. Second point, pi over 3 and 1 over 2. So this is pi over 3 is 6, pi over 4, pi over 3 and 1 over 2. That on P1, P2, P3, P4, like that. So here I am. Am I right? Let that one be 1 over 2. How about P3? Here I am. 1 and pi over 2. How about P4? Here I am. 1, 2. So I'm going to sketch the graph like that. And I got half of the shape. And of course, if you take more, you'll get more or beautiful. How about the second part? Because of symmetry, I say what? I say that one is like that. Amahariyaka, that one is 1 and pi in P4. So P4, this one will reflect of P4. That one will reflect of P2. And that one will be the reflect of P4. You got it, Jamaat? That point is what? 2 and pi. So here you are, the symmetry, the points, and the angles, and the graph. Do you have any question about the graph? Later, I will give you some trick to sketch the graph of one sine, one cosine. How if I change that one to, for example, 1 plus r equal to 1 plus cosine theta. We change like that. How about if I say 1 minus sine theta? The shape will be like that. How else is I'll say pi? The shape will be like that. So don't worry about that. I'm going to give you. Any question about the graph? Dears? Good. I can see you are very tired because it's a little bit boring because you didn't practice, because you don't know how to sketch point. Good. Notes about silent. We didn't finish yet. Notes about what? Notes about symmetry. Yeah. If you have two symmetry, then, well, let me see, if you have two symmetry, then you have the third also. So buy two, get one free. Understood what I say? For example, if it's a symmetry about x and origin, so do not check the about. Also should be symmetry about y-axis. I gave you the example of the floor for, it's called 4 rows. And look at here. 4 leafed or 4 petals rows. So in that case, that one is symmetry. Look, I'm going to highlight it. This one is the original one. You can say symmetry. You can find symmetry about x-axis. As well, you can find symmetry about y-axis. So do not think about the origin. Of course, you have an origin. Or you can say somebody else say, the other students say no. It's symmetry about y-axis, here I am, and symmetry about x-axis. I can give you the guarantee for origin. Or you can say symmetry about origin, and also symmetry about x-axis. I say do not check the y, and go on, all of them. So if you have two, the other one will be free, so do not check it. Okay? So that's why I say buy two. Okay. So if it's the second note, if it's not one of them, is not is just is not one of them. How can I explain? Okay, let me restate it. If it's one symmetry and not second symmetry, then is not third symmetry. Why? For example, if it's x about x symmetry, yes, but it's not about y, so you don't need to check the origin if you did correctly. I see. Why you don't need to check? Because if it's a x and y, of course you need to. If it's a x and y, so of course it should be origin one, or maybe the conflict with the first one. That's why. Do you understand what I say? For example, if it's a symmetry about x-axis, and I check it, is not symmetry about y-axis, right? So of course it's not symmetry about origin. Just it will be what? One of them. If I have one and none, so it means that is not the third one. I have one exist, one symmetry, the second is not, so do not buy the third one. The third one is not. Do not try it. Understood what I say? Good. That's all about symmetry. So next lecture, I'll give you the standard form and we are sketching more.